Hi, my name is Georgia Warmbein, and this is my honors project for Chemistry 252. I will be discussing salicylic acid and its organic properties. In this video, I will explain what salicylic acid is, its structure, properties, and importance to pharmacology. Salicylic acid is a colorless, crystalline organic carboxylic acid. You may have encountered this chemical in the skincare aisle of a drugstore. It is a common and key additive in many skincare products for the treatment of acne, psoriasis, calluses, corns, and warts. Salicylic acid is able to treat these problems because it can stop bacteria from growing and kill fungus. Salicylic acid contains a benzene ring with an alcohol and carboxyl group attached on adjacent carbons. The carboxyl group can react with alcohols to form useful esters. Due to its benzene ring, salicylic acid is nonpolar and insoluble in water. Salicylic acid has a pH of 2.98, meaning it is highly acidic. Salicylic acid can be made in a lab or derived naturally. Leaves of white willow trees or wintergreens contain some salicylic acid that can be derived. This is the mechanism of synthesizing salicylic acid in a lab. As mentioned previously, salicylic acid is used in many skincare products. A common use is for acne treatment. This works by unclogging pores in the skin. Due to its chemical structure, salicylic acid can penetrate deep into the skin for intense cleaning. In addition, it works as a peeling agent on the skin. This ability is important for other skin issues such as psoriasis and calluses. On the left, you can see before and after pictures of a woman treated with a salicylic acid peel. This treatment is used to soften fine lines on the skin and boost complexion, as well as treat sun damage. Salicylic acid is a derivative of other common pharmaceuticals, including aspirin and Pepto-Bismol. Aspirin is commonly used to treat minor aches and pains, inflammation, and fever. Pepto-Bismol is a common drug used to treat stomach discomfort and heartburn. This shows salicylic acid in the middle, the structure of aspirin on the left, and Pepto-Bismol on the right. As you can see, these molecules are very similar. Pepto-Bismol and aspirin are derivatives of salicylic acid. Salicylic acid is also used in small amounts to preserve food. This works because it inhibits growth of bacteria that cause food spoilage. In addition, salicylic acid kills fungus, which can cause food to spoil as well. It is important to realize that salicylic acid is toxic and dangerous. The uses I have mentioned for salicylic acid usually contain very low concentrations of it. At higher concentrations, salicylic acid can be extremely harmful and cause chemical burns. If salicylic acid contacts the skin or eyes at high concentrations, it's important to get medical aid and flush the affected area with water. If ingested, salicylism may occur, which is characterized by headache, dizziness, difficulty of hearing, confusion, and other side effects. Chronic exposure is repeated exposure over a long period of time. With salicylic acid, this may result in reproductive and fetal effects. The lethal dosage of salicylic acid is 480 milligrams per kilogram of mouse. This means that 480 milligrams of salicylic acid for every 1 kilogram body weight of the mouse, when administered in one dose by mouth, causes death of 50% of the test group. Here is the list of websites I referenced while making this video. Thank you for watching.